Number one, your first equation has y isolated, like by itself, equals x plus 5. Yeah, you always want to look for that. Either it's the second equation or the first equation, it doesn't matter. So since that is the first equation, actually I'll write that one, but on the next problem I won't. So since y is actually by itself, you want to plug that into the y of the other equation, wherever it is. So here it is. So I'll write it this way. I think you'll be okay. So y happens to be, I even group it. I recommend you group it with the parentheses no matter what. Okay, whether there's something in front or behind, it doesn't matter. It's minus, especially when it's minus the y. Okay, so here it is. So I plugged in the y that is equals to x plus 5 into the second equation. It looks like that. Okay, then continue. Just combine like terms. There's nothing to distribute, so just go ahead and imagine without the parentheses. So combine like terms, that's going to be 4x, sorry. It's 4x plus 5 equals 25. Subtract both sides by 5. So left with 4x equals 20. Divide both sides by 4. So x equals 5. So right now, your answer for x is 5. Now, sometimes you get y first. It doesn't matter, okay? So you have to solve for x and y. So it's like this. X equals what? Y equals what? Sometimes your teacher wants you to write it in a coordinate form. You know what I'm talking about? Like the x comma y thing. So it depends. So right now, I'll write it x equals 5, but I'll put it in the coordinate 5 right here. Then I'll solve for y in a second. Okay, now, once you have x, all you need is to crank out 1. It doesn't matter which one first. Then once you get one of them, one x or y, you can plug in anywhere that you think is fastest. So here, I put it in right there in the first equation. So I'll put it in the first equation to get my y the fastest. So I get my y equals 5 plus 5. The 5, that I put in is right here. Therefore, y equals 10. That's it, the final answer. Then you can put it in the coordinate form you want, right there. But I'll bubble everything. Bubble the x by equals 5, bubble y equals 10, and then 5 comma 10. Sometimes the teacher wanted it like that. So I'll do it. I'll do all of that. Okay, so done. Let's do the next one. Q. Okay, see, look, they even actually holding your hand. They're actually have the x isolated for you. So I won't copy that. Well, I'll copy it. Okay, so since x equals y minus 2, I'll put that in where the x is in the second equation. Here's this x in the second equation. It's right behind the 4. So, but you have to parenthesize it. Please parenthesize it always as a rule, no matter what you do. Yeah, when you're plugging in like a long, like y plus whatever, like something long, put the parenthesis around it. Plus y equals 2. You follow, okay? I plug it in where the x is, and then write out everything that's behind it. And now continue, distribute to solve for y. This time you solve for y first. So 4y minus 8 plus y equals 2. And then combine like terms. 5y minus 8 equals 2. I mean, I would have done adding 8 at the same time, by the way, both sides. So now add 8 to both sides. So 5y equals 10. Divide both sides by 5. Y equals 2. So that's your first variable that you got. Y equals 2. So if I were to put it in the coordinate, it'll look like this first. The y gets filled in first. Okay, then plug it wherever that's fastest. I'll put it in the original right there. It doesn't have to be the original. It could be a modified one. But you'll see what I mean by that when you do elimination or addition method. Okay, now I'm solving for x. So I plug in the y. Even when I plug in, look at the 2, right? I still put a parenthesis around it. That is to emphasize or show that you plug it in. You don't have to for a single number, a single variable. You don't have to worry about it, but I would do it. So it equals 0. So x equals 0. Y equals 2. Right there. Now, you can always check the answer. It doesn't say, remember I was saying that later on you're likely to be asked to check your solutions. Not right now, but if you want to, you kind of can, especially when you get a 0. Let's quickly look at number 2. Watch. The first equation, right? This one right here. If my x is 0, my y is 2. Yeah, 2 minus 2 is 0. See that? Now you can mentally check it. You could do the second equation also if you want. So yeah, 4 times 0. Look at that. The second equation. Look at the second equation, right? 4 times 0 is equals to 2. You know, like 2 equals 2. I mean, anyway, we'll do that by writing, but we want to continue. Number 3. Okay. Here we go. Notice nothing is solved or isolated. But look at the first equation, right? The y looks good to solve, right? The y by itself. So what I would do, I'll go ahead and I'll do the first equation solving for y. So we do this on our own. So subtract both sides by 3x, subtract both sides by 3x to get y by itself. You could either write, there's 2 ways of writing the y. You can either write 6 minus 3x or negative 3x plus 6. Which one do you want to write? You know what? I'm sorry. Let me write. Let me tell you what I think you should write, because it might be important later on. I recommend you write 3x plus 6 because it looks linear. Remember mx plus b? Remember that stuff? Yeah, let's keep it like that. Now, you can get fancy and write, hey, y equals 6 minus x. No problem, because this is actually what I would have done, or what I would have used. Because it's easier when you distribute or plug it back in. It's clean, but it's up to you. You can do either one. But let's do this one first, linear, make it look linear. But then I'll do the next one like that. It doesn't matter because you're not graphing. Sorry, you're not graphing or anything. But okay, so y equals that. Let's plug it into the second equation. So it will look like this. So 4x stays 4x, but 2 times y is going to look like this now. 3x, negative 3x plus 6. Now, I take it back. You could have actually put that in here instead. It doesn't matter. The answer will still be the same. Again, you're not graphing, so yeah. But I'll write it like this for this one, and maybe the next one another way. So equals to 8. Double check my math, okay? Distribute the 2. So, but yeah, keep the 4x though. Sorry, write the 4x first. 2 times negative 6x plus 12 equals 8. Okay, combine like terms. Right there, you get negative 2x plus 12 equals 8. Subtract both sides by 12. You're left with negative 2x equals negative 4, I think. Yeah. Divide both sides by negative 2. So you're left with, so your x is positive 2. You got this one first. Here we go. You're allowed to plug it wherever you want, wherever you have written, even the step you already have written. So I'll plug it in right here because y is by itself, you see? So I'll plug it in right here. So here, I'll put it out to the side here. Y equals negative 3 times 2 plus 6. You can put it wherever, but what you want to plug in, where you want to plug in. I plug it in right there. So it becomes negative 6 plus 6. Therefore, y equals to 0. Negative 6 plus 6 is 0. So there you go. And then you can put in the coordinate form. What is that? 2 comma 0 for number 3. We'll come back and check it if we can. We have time. So let's continue. Number 4. Oops. Number 4. Sorry. All right, 4. Okay, then, okay, now, see, look, this is where you probably want to do another method, but we're going to follow the instruction by substitution again. This one could have been done differently and cleaner than what we're about to do by substitution. Yeah, so addition method. Hey, can I ask, are you allowed to do addition right now or no?
Oh, no.
Okay, no, let's don't do it. That's no problem. Okay, so this one, you could kind of eye it. Which one you want to solve a variable for, x or y? It doesn't matter. I mean, okay, because I'm looking at both. You're going to gain fractions, so be ready, okay? You have no choice. Deal with the fractions. Don't worry. We'll deal with it. I'll go ahead and solve for x in the first equation. Yeah, if you kind of like look around for something that you can solve for fast. Why am I doing the first one? Because the coefficient, the numbers, and the constant, they're smaller than the second equation. So I'll do that. So let's do that. It doesn't matter which one you solve for, x or y, but I'll solve for x. Equals 4. So I'll copy the first equation and solve for it. Or here we go, solve for x. Subtract both sides by 3y. Okay, check this out. I'm about to do something that may look strange, but it's not a big deal. So subtract both sides by 3y. 2x, it's left by itself. But here on this side, I recommend you write it this way now, this time. Do 4 minus 3y. They're not combinable, but just write it like that. Instead of writing negative y plus 4, sometimes the negative is, it can, look awkward in the front. So let's do it like that. And then divide everything by 2. Everything by 2. So normally they bar the whole thing, and then, and then you go and continue with it. Now, from here, though, I think you can do two things. You could either leave it like that, no kidding, and plug it into chunky looking like that. Plug it into the second the second equation looking like that. Let me look carefully, okay? If that, yeah, you know what? You could technically do that. Look, let me show you two ways. You either plug that whole thing in like that, or you split them. You remember that you can split them into this? But you tell me, okay, if you're comfortable, or you know that this is what's happening here. If I simplify this into something else, it'll be this. 4 divided by 2 is 2, but then you have 3 halves y. Is that okay?
Yeah.
You understand? Like 2, you can divide 4 by 2, and then the minus 3y by 2 also. So it's split into 2 like that. Now, if I were you, I wouldn't even bother doing this. I would plug this whole thing into the second equation. But let's do it with this one. I believe the book want you to use the split form and plug it in. I don't know that, but I believe that's what maybe your teacher have taught you to put in the whole chunkier rational expression, that's what they call it, into the second equation. I'll do both, but I'll show you what each one will look like. So here, I'll plug in this one first. Well, wait, let me write it right here, okay? So it looks like this. I hope you're okay with that. The x turned into this if you want to continue further. Now I'm going to plug this whole thing into the second equation. So where is it? Okay, it's going to be right behind 4. Parenthesize it, okay? The whole thing. And then plus 6y equals 9. Double check my math. Okay? All right.
Yeah.
Distribute. I know I bubble a bunch of things. I hope it's not confusing. So distribute. When I do, I get 8 minus, oh, here we go. There's a math here. See how fast. Remember I was telling you that you can, is it you? Let me double check. Let me think. Yeah, I think it's you. Let's see if you can mentally simplify this. You imagine a 4 in front of 3 halves. 2 can go into 4 2 times itself 1 time, so you don't care about that. Therefore, you're left with 2 times 3, which is 6y. Can you see it that fast? Or you can see 12 divided by 2, like 4 times 3, right? Divided by 2, 12 divided by 2. But I recommend you learn to mentally cross-cancel it. Imagine 2 in front like this. This is what I see in my head. 2, the minus stays minus. I don't think negative. Okay, I put the minus way out early. So what I see in my head is that I squeeze the 4 in right here. This is what I see. 3 halves. Y. I don't even look at the y, by the way. Okay, ignore the y. So I squeeze that in the front. Then I imagine 2 can go into 4 2 times. That's it. I don't care about the itself 1 time. Then I do 2 times 3. You see that? I hope you're okay. So I think you'll get more practice doing this, so you shouldn't have to worry. Yeah, This is what it's about. You can speed things up a little more and more each time you practice, right? Or you continue, plus 6y equals 9. Okay, something's happening here. I'll check in a second. I'll double check it in a second. Okay, so if you continue, did I make any error? Let me double check. Yeah, it looks good to me. All right, if I continue, this is what's happening. This canceled out, dude. You see that? Negative 6y plus 6y,
Yeah.
they canceled out. So you're left with 8 equals 9. What's wrong with this? Have your teacher mentioned something about this? Now, I'll go back and check. But when this happens, right, when you do your work and you come down to something odd like this, and it's not true, right? You're left with 8 equals 9, which is not true. Guess what? You would stop immediately and say there is no solution to this equation. Is that okay? There is no
Yeah.
solution to this equation. So what you're going to do is you're going to say no solution. Or I don't know what your teacher does. Sometimes they use empty set. This circle, very round circle, and then a slash through. But I would recommend just write no solution. But I will double check that again quickly, okay? Yeah, but I think it's right. Double check quickly. Yeah, it looks good to me. If I continue. Yep. Yep. And 6y. Yeah. Okay, so have your teacher talked about this yet? Like, there's one more variation, by the way. There's a no solution, and then of course the one we've done x and y. You get the solution. You get the answer to them, and there's just one more. It's called infinite number of solution or all real numbers. That's another type. So that's coming up. I think if this happens, the other one's going to happen too. So let's continue with 5, but I'll check 4 again later on. I'll use like the fancy app to check it quickly too. It doesn't matter. Anyway, let's do 5. So no solution. Yeah, if you continue and you come across something that's not true, equals to something, something is not equal to something else. But when you come across like something like 5 equals 5, that's another variation. When you ever come across that in your step, guess what? That is the next variation. It's like the no all real numbers, no infinite number of solutions. So that's another thing. I think it's coming up. Okay, let's do 5. I hope this is the one. Okay, this one is pretty nice. I'm gonna solve for x in the first equation. From the first equation. You see why? Because it looks good. I don't want to solve for y because x is positive. So I'll solve for x and I'll plug it in to the second equation. So here we go. Add both sides by y. So x is by itself. On this side is y plus 1 or 1 plus y. I'll do y plus 1. And then I'll plug it into the second equation. Now, the second equation, I don't know, some students are pretty clever and, they divide everything by 3 to get rid of all the 3's. Can you imagine that, right? You see that? I'm not going to do that just now because I don't want it to look confusing. So let me plug it in. So here we go. I'm going to plug in the x with y plus 1 on the left side. The right side is still 3y plus 3. You get that? Is that okay? You see it?
Yeah.
So here it is, dude. Number 5 is the next variation that I was telling you about. What do you mean? Here we go. Let's distribute. Let's take a look, okay? 3y plus 3 equals 3y plus 3. Take a look. Now, you could stop right now. You don't have to continue further, but you could. But it won't make a difference. Look, this is something pretty fancy. If you, if you do your substitution, whatever, simplify it a little bit, and you come across something that looks the same on both sides of the equation, you can stop. And then you say, infinite number of solution. There are different ways that depend on what your teacher wants. Infinite number of solution. Infinite number of solutions. Or all real numbers. Or this fancy symbol, all real numbers. So that means I don't want to check 4 now because I believe it's true. I'm pretty sure it's right. Yeah, because it's covering all the possible type of solutions, right? All real numbers. Or this fancy symbol, depending on what you want to write. or negative infinity, positive infinity. I don't know. You're okay with that? Yeah, but no, you don't have to write that. That's yeah. Don't worry about that one. But there it is. You can write infinite number solution, all real numbers, or the real all real numbers symbol. Now, before I continue, have a look. If you were to continue with this step, right, it would look like this. Watch, okay? You can continue infinitely, by the way, but I'll show you a little bit. So I'm going to subtract both sides by 3y. Subtract both sides by 3y. They cancel. You're left with 3 equals 3. That's also true. You see that? You don't have to do it, okay? But those students who are like pretty comfortable, they will stop right here immediately. Or teacher should have taught you guys to do that. Okay. So anyway, if you want to continue, get that. If you want to continue further, you can. How? Subtract both sides by 3. You get 0. You get 0, but it's still true. Every single step is true. Everything equals to itself. Get it? Like, yeah, you don't have to continue. That's why you don't want to continue further. You can stop right there. So more advanced student, like, I'm sorry, later math, they know to do this. But some of you guys still continue to do this far, like a number equals a number. You don't have to do that anymore. So since I point this out, don't expend energy and time doing that because it will turn into whatever you want it to be. Same. 003355, whatever. You can make a 5 out of it. How? Or negative 5. Subtract both sides by 5. Therefore, I get a negative 5 equals to negative 5. I'll add both sides. It doesn't matter. That's what I mean about it. It's continue infinitely. You can make it whatever you want. You can make a 99 out of it. If you at 0, you could go ahead and add both sides by 99. You get 99 equals 99. You get it? That's what I mean. It's like, yeah. So don't waste your time. You stop right there. So that's it. Right, continue. Number 6. Okay. So get
Yeah.
ready. Get ready for the two possible variation. The special cases, like, hey, I don't know. I don't want to call special cases. No solution and all real. Infinite number solution. Number 6. Okay, if you look at number 6, right? Again, the first equation would be the one I do. I solve the y for. Solve the variable for. Okay, look at how I would do this, okay? This is pretty fancy. I'm going to solve for y in the first equation. How? Look at the way I'm going to do it, okay? Add both sides by y. This is going to be fancy. Subtract both sides by 6. Let me see if you get this, okay? The y is only left by itself on the right side. The left side is 2x minus 6. What do you think about that? I don't think you guys would do this. It's yeah, I don't think you guys would do this because most of you guys would do it like this. But the reason I did it because I don't want to see negative in front of anything or in front of the variable, especially. But most of you guys would do it this way. It's okay. Either way, it's fine. Subtract both sides by this, you get this, right? Like 6 minus 2x. And then you cannot have negative. You have to divide or multiply everything by negative 1. So if I do that, you get y equals positive 6 plus 2x. Wait, negative 6 plus 2x. Do you know they're the same, right? Could you see that? They're the same thing.
Yeah.
Yeah. So, but mine looks cleaner. But look at all this messy thing that I introduced. Do you want to see how I did it again? Back to this one, okay? I do this mentally, by the way. If you do enough, you don't. It's not because I did a lot, but I think you could even do it right now. Try to imagine it. Use your imagination. Add both sides by y, right there. Subtract both sides by 6, right there. I don't even have to write this if you don't want to. You get it? So it's clean
Yeah.
looking if you do it this way. Okay, so let's continue. But you can do it any way you want as long as you're comfortable at it being right. Isolating the variable, okay? All right, plug the whatever you get for y into the second equation. So here is the second equation. It comes with the negative 3 in the front. So I'll parenthesize what I plug in right there. And then on the right side, stay as is. So far, okay? Right, distribute. So I get a negative 6x plus 18. We stop again. So they're actually trying to train you to actually be ready for the all real and no solution type. See that? Stop. Yeah, we don't want to continue right now. You want to stop and then say all real numbers or infinite number solution, all real numbers. Infinite numbers. You can write one or the other. You can write all of it if you want. Infinite number solution. Infinite number. This is actually more correct, by the way. You say infinite number solution. Okay. All right. Continue on. 8 to 22. Sorry. All right. 8. It's still substitution. Okay. All right. Number 8. Right. They already isolate the variable for you. So I'll plug in the 5x plus 1 into the y in the second equation. It looks like this. Here's the second equation plugged in with the y. I'll parenthesize it still. 5x plus 1 equals 10. Is that okay?
Yeah.
Double check. Yeah. Okay, then there's nothing in front of the parentheses. Therefore, you can ignore the parentheses and combine like terms. So therefore, it's 9x plus 1. Oops, I write 5. 9x plus 1 equals 10. Subtract both sides by 1. You're left with 9x equals 9. Therefore, divide both sides by 9. You get 1. And stop right there. And then solve for y. So to solve for y, you can plug it in wherever you want. Plug it in the first equation. It has y by itself already. So I plug in into the x in the first equation, which is going to be 1. 5 times 1 plus 1. So y equals 6. Is that okay? So in a coordinate form, it's going to be 1 comma 6. Okay. Continue. Number 9. I don't know why it's green, bold shade in green for that number. Let's see. It might be something fancy. All right. I'm going to plug in the y into the second equation again. It's already solved, so you want to use that. So if I plug in the second equation, I'll get 2x plus 4x plus 5 equals 17. You see that okay? Double check. Yeah.
Yeah.
Okay, then combine like terms. Again, nothing in front to distribute. So it'll be 6x plus 5 equals 17. Subtract both sides by 5. You're left with 6x equals 12. So then divide both sides by 6, so x equals 2. Or 6 times 2 equals 12. So we're done with the x. Now plug in the x being 2 into the y, into the x for the y. So y equals 4 times 2, first equation, plus 5. So y equals 8 plus 5. So y equals 13. Okay, so it's 2 comma 13. Okay, continue for 10. Okay, 10 is fancy. Are you ready? So you're going to come across this eventually. Nothing fancy, nothing different, any different. Okay, check this out. This is actually very common, this problem. Well, even later on. You see y equals y, like y is y. Therefore, you can write it like this. You can plug in the first into the second into the first. It doesn't really matter. It will look like this. Here we go. Doesn't matter which one on which side. Let me see you're okay with this. Since y equals y, therefore the two expressions equal to each other. You see it?
Yeah.
Yeah, it doesn't matter which side is what. 3x minus 34 first, you can write if you want equals to 2x minus 5. It doesn't matter. Okay, continue from here. But have a look since I'm I've been showing you a bunch of things that can be helpful here. I think I've been showing something helpful. Look at this here. How would you solve this? You see that the 3x is a bigger x than 2x. I would subtract. I would have the x on the right side and leave it there, because you don't want a negative x anywhere. So subtract both sides by x. So this is what I'm doing always. Every time I come across something like this, I always I look for what dictates the x going to be on the left and the right. In this case, it's going to be on the right. So I subtract the 2x away. Then I will leave the 5x. I'm sorry, the negative 5 alone. So I have x now a positive. That's what I want by itself. And then I can add 34 away. I want the x to be on the right side, positive, plus 34. Okay, so now you got x equals, what is that? 29, I think.
Yeah, 29.
Okay, so that's it for x. Then now what about for y? Well, you can plug it in. Here it is. Guess what? You can plug it in wherever you want. They will give you the same answer, whether you believe it or not. But I'm sure you probably see the reasoning behind it. So therefore, I'll plug it into the second equation because it's smaller than the first. But you can plug in the first; it will give you the same y, exact same y values. Trust me, yeah. As long as we got as long as we solved this correctly, I'm sure we did. So if we go 2 times 29 minus 5, I'll put it in the smaller one, the one that's cleaner, 29. 2 times 29 minus 5. Okay, what is that? 58 minus 5.
Yeah.
Okay. So y equals 53? Yeah. Okay, so in coordinate form, 29 comma 53. Yeah, they're trying to show you that, hey, the answer could be big or small or fraction or decimal. I think you're eventually going to get it. A fraction, you're probably going to get a decimal. Well, a fraction is decimal. Or 10, 11, same way. Hey, so I'll skip 11. I'll let you do that. Yeah, leave a little gap. Is that okay?
Yeah.
I want to look at, because it will be the same like number 10. Number 12. Everything is good. I think you can do all of it. Let's just continue. I'm sorry. Let's just continue because I think you can. I don't think there's anything tricky, but just be ready for the answer being like the same on both sides, like, and then also one more time. If you come across in your step somewhere like 10 on one side and then you somehow see a 99 on the other side, something like that, then you slash through. Is that okay? If you ever come across something that doesn't make sense, then you say no solution.
Mm-hmm.
Yeah, we only come across that once. All right, let's continue. 11. Okay, I would write them side by on the same row. Y equals y, so therefore it's just going to be the two expression equal to each other. The 3x minus 2 equals 2x minus 5. And then solve. Okay, now the 3x is bigger on the left side, so I'm going to subtract the 2x away. So I'm left with, okay, I'm going to do simultaneous work here. I'm going to add both sides by 2 at the same time. I could have done that earlier on, by the way. So now, therefore, I'm left with just x, and then I'm left with just negative 3 on this side. Double check my math there. Add both sides by 2x. Yeah, then add both sides by 2. Yeah, they cancel there. Okay, I got my x. Now I'm going to plug that into the y. Any y. You can plug in any y you want. Look, number 10 has the second equation the same. I don't know if you pay attention. The y in number 10 is the same as y in number 11, the second one. Doesn't matter. So I'll plug it into the first one. So y equals 3 times negative 3. You can plug it in the second equation. It'll be the same answer if you didn't know. Actually, I'm going to do that right now to show it to you. So anyway, I got my negative 9 minus 2, so it's going to be negative 11. So for the y, but watch, I'm going to plug into the second equation. This is y1, y2. So watch, I'll plug it in for you to see. You don't have to do it, okay? So I'm going to plug in -3 into the second equation. 2 times -3 minus 5. Take a look. So y equals -6 minus 5, same y. See, same answer, -11. Doesn't matter which one you plug in. So I just wanted to show you that. Okay, good. So put it in coordinate form if you want to. -3 comma -11. Okay, next one. Number 12. Okay, so 12. I would solve for y in the first equation. Now, solve for y in the first equation. So if I solve for y in the first equation, could you see it's going to be this? Can you mentally see that? For number 12. I subtract both sides by 2x, but I'm going to put it right behind the 3. It's clean. You can put it in front of the 3. It'll be a -2x plus 3. So this is my y, mentally. Then I'll plug that y, or the 3 minus 2x, into the second equation for the y, okay? So it'd be 4x plus 4 times that whole thing equals to 8. Hey, so I want to point out this. I want to point out that the second equation could also be reduced to a. See, you can see it. You don't have to. Anyway, don't worry. I mean, I would have done an x plus y equals 2. I don't know. You can see that I divide everything by 4. But let's just be clean and continue. It's not that big of a deal right now. So distribute. So it'll be 4x plus 12 minus 8x equals 8. So double check. Yeah. Combine like terms, this and this. It'll be -4x. Then I'll subtract 12 over. So left with -4 on the other side. So x is going to be -1 divided both sides by -4. And then I'm going to plug it into what I manipulated the y, or what I solved the y, what I got the y to be, right? I solved for y mentally. So I plug it in there. This is what I'll get. So it'll become 3 minus 2 times 1, which is going to be 3 minus 2, which is going to be 1. 1 comma 1. And then you probably mentally see that. So the answer is, in the coordinate form, is 1 comma 1, like that. Okay. All right. 12, 13. I know you could finish this on your own, but let me do a little more here. I want to see the no solution one. Actually, I can scan for it if you want me to see it. Okay, I know you can do 13, but let me scan for the one that may give you no solution in a second here. Let me see here. 16, maybe. And you probably ask me, how do you even know? How do you even know? Well, the easy one is the infinite number solution, if you want to know. Actually, I may want to show it to you. Okay, look. Let me show you the easy one first. How do you know how do you know an infinite number solution? Let me look back. Watch. How do you know if you can identify the infinite number solution? And no solution also, right? But let's do the easy one first. Infinite number solution. Look at this one, number 6. Yeah, I know it's on another page, but number 6. Could you scroll back to number 6? I want to see the original. Okay, number 6. Man, they wrote it so that you can actually easily identify it. But you can. But you probably don't want to, because, man, let me think. You know what? Don't worry. You can do it, but you don't need to, because the numbers are not that bad. You can deal with. Let's continue. 13. I'm sorry. Yeah, there's way to identify it if you can make them the same. Okay, I'll tell you how you can do it. If you ever see an equation to be the same, like the top and the bottom, but how do you know it's gonna the same? I'll make up right now. Now, before I do 13, this is just an example. I'm making this up, okay? Watch. If you come across a problem that looks like this, you got 2x plus 2y equals 2. They don't look the same at first, right? Sometimes they make the y on the other side, whatever. But right now, pretend that you actually see this, like you make them all in a line, like the x and the y and columns and the number. Look this here, right? Could you tell that if I divide this equation, the second equation by 2, it's the same thing as the first equation? Do you see that? If I divide this one by 2, everything by 2, I'll get the first equation. Do you see that?
Yeah.
If
Yes.
you can tell that they're the same equation, this one has infinite number of solution immediately. But obviously the ones that you were working on, they made it so that you cannot easily see it. They isolate the y on the other side, whatever, so that you don't see it right off the bat. So, but now what about the one that has no solution? Well, here we go. Let's do it. If you can identify it, but if you don't worry. Have a look, okay? I'm making this up, but then I'll modify it. I'll do it too. Okay, so look, if you can tell that the x and the y are the same somehow, and then the number kind are different, immediately there's no solution. Yeah, so if you wonder why, don't worry, I'll show you next time. But they're not going to write it this simple. They're going to make it look like this. Check it out. They're probably going to multiply it, this equation or this equation. Oh, no, this equation by -5. So it'd be -5, and then a -10 here. See? Like that. So it will look like this instead. But why is this important? It can be important when you need to actually speed things up. Imagine that, right? On the test, you'll be expending energy and time trying to actually solve a problem while you already know that you cannot solve. Therefore, you can, it's helpful. So here's the no solution one. I'm making this up. There it is. So if you try to solve this problem, it will never work. But there's another way to identify it. If you can actually look at the coefficient, like the number in front of the x and y, if you can make them all the same, like literally, right? Or at least the same for x and the same for y, then there's no solution. This here better be different. But anyway, don't worry about this because they, like I said, they made them so that you cannot identify easily. So therefore, just continue with it for practice, right? For practice. Hey, so I'll let you finish everything else. Just look out for, be aware. If you continue, you don't see that they're matching up on one side, the other, then you say no solution. If you can identify right away that they're the same on both sides, then infinite number of solutions. Is that okay?
Yeah.
All right, Alex.